Hello and welcome students. This is another lecture on lines and planes. In last lecture, we solved problems on finding equation of line when we were given one point on the line and a vector parallel to the line. Now in this lecture, we will see how to find equation of a line when we are given 2 points on the line. The theory regarding this particular problem had been done in the last lecture itself. The theory we did in the last lecture, where we saw the detailed derivation of finding the equation of a line when we have 2 points on the line. So here we have exercise 6.1, question number 2. See what the question is. The question here is, find the vector equation of the line passing through points having the position vectors 3i cap plus 4j cap minus 7k cap and 6i cap minus j cap plus 3k cap. What are these two? What are these two? They are the position vector of points given on the line. So see, when we are given lines, when we are given points on the line, they can either give us the coordinates of the point or they can give us the position vector of the points. Now, if they are giving us the coordinates of points, ultimately you understand that we will have to find the position vector only. If they give the coordinates, still we will have to find the position vector. Now, when they directly give us the position vector, one way it is good for us because they are helping us by giving the position vector, and the length of the solution will become reduced for us. So see, this is OA bar. Here what they give is, suppose I assume that let the points be point A and B. So I have the position vector of one point as A bar, the other point position vector is B bar, and what they give me here are the position vectors. That is, they give me A bar and B bar. What they give me are A bar and B bar. So here I will write this. I'll write it here. So my solution begins. I write, let A and B, let A and B be 2 points on the line. Let A and B be the 2 points on the line. Therefore, now what they give me here is the position vector of those 2 points. These are the position vector of those 2 points. So they are A bar and B bar. So A bar is 3i cap plus 4j cap minus 7k cap. And B bar is 6i cap minus j cap plus k cap. Okay. I will find out AB bar. Let us find out AB bar, students. Why? Because you know, in this case, we are not given the parallel vectors. We are not given the parallel vector B bar. You remember, for finding the equation of a line, the minimum required things are one point on the line and a vector parallel to the line. But now in this case, the vector parallel is not given. The parallel vector role is being played by AB bar. This AB bar would be helping us for getting the direction of the line. So I will find out AB bar. Let me now find out AB bar. What B bar was doing for us. Remember, I say this again. What vector B bar was doing for us in the earlier theory is now being done by AB bar. So I will find out AB bar. What is AB bar? See students, AB bar is, therefore AB bar is B bar minus A bar. So B bar minus A bar, 6 I cap minus 3 I cap is 3 I cap minus 5 J cap minus 5 J cap minus J cap minus 4 J cap is minus 5 J cap. And this is K cap minus of minus 7 K cap, that is plus 7. So this is plus 8 K cap. We got AB bar. Okay. This is AB bar. What is the next step? The next step is now I take a variable point on, variable point has to be there because that is what is going to give me the line. Variable point is the point which will construct the whole line for me. So I will write let point R, let R be a variable point on the line, and R bar will be the position vector of that point. So here I write let point R be a variable point, be a variable point on the line. And I will write position vector of R as R bar. R and then bracket R bar. Let point R bar be a variable point on the line. See, now what I see here, that two vectors here. Number one, AB bar, and number two, AR bar. These two vectors. You check two vectors, AB bar and AR bar. They are collinear to each other. Vector AB bar and vector AR bar is collinear to each other. You all have to agree to it, right? AB bar and AR bar, these two vectors are collinear to each other. I will write the vectors AB bar and AR bar are collinear vectors. Therefore, we can write what we will be able to write here. Therefore, we can write AR bar equals to lambda AB bar. You see this? AR bar equals to lambda AB bar. This AB bar you have already found, students. You see this? So I will have therefore R bar minus A bar equals to lambda. AB bar you have already found. That is 3 minus 5, 8. 3 minus 5 plus 8. Now this A bar you will shift on the right side. So R bar equals to A bar plus lambda 3 I cap minus 5 J cap plus 8 K cap. So you have therefore R bar equals to A bar is, what is A bar? A bar is this 3, 4 minus 5. 3 I cap plus 4 J cap minus 5 K cap. This is A bar plus lambda times 3 I cap minus 5 J cap plus 8 K cap. And this is equation of line. This is the required equation of line. This is required equation of line. Okay, so let's go for the next question. Question number 7 here we have. See, I'm not following the proper sequence. I'm not following the sequence of the, I'm not following the order given in the textbook. That is, you must have noticed I'm not solving question number 1, 2, 3. I'm following the sequence of easiness and the sequence of the theory. As we are doing a particular theory, we are solving all problems based on that theory. So here now the next question is, once again we are given 2 points on the line and we have to find the equation of the line. But this time see what is said. It says find the Cartesian equation. What does it say? It says find the Cartesian equations. We have to find the Cartesian equations of the line passing through A. See, passing through one point A, 221 and B, 130. So there are 2 points once again given on the line. What are the 2 points given on the line? A and B. But this time we have to find the Cartesian equation. No issue, absolutely no issue. We can do it very easily. So what we will do is we draw a line. On that line we have 2 points A, 221 and B, 130. What more we will do? We will take a variable point on the line, and the variable point we take is our x comma y comma z, right? Do we have to write the position vector of these all points? Absolutely not. This time we don't need position vector, nothing. Okay. So here I start writing the solution as follows. See, I will start with the solution. I will write, let the answer starts with the diagram itself. I will write here, given A 221 and B 130 are 2 points on the line. On the line, I will write, let Rx comma y comma z be a variable point on the line. Be a variable point on the line. I will write the equation of line can be given as, how it can be given? See students, it is x minus x1 upon x2 minus x1 equals to y minus y1 upon y2 minus y1 equals to z minus z1 equals to z minus z1 upon z2 minus z1. That is, see here, x minus x1. So x1, y1, z1 I have here, right? And x2, y2, z2 are the coordinates of point B. So I write x minus x1. That is x minus 2 upon x minus 2 upon x2 minus x1. 1 minus 2. You see this? 1 minus 2. Okay. See, these three are x1, y1, z1. They are x1, y1, z1. And these three are x2, y2, z2. x2, y2, z2. You see this? Okay. No need to write in the diagram. Just for your reference I wrote. So x minus x2 upon 1 minus 2 equals to y minus y1. So y minus 2 upon 3 minus 2 equals to z minus 1 upon z2 minus 0 minus 1. So this is, that is, you have x minus 2 upon minus 1 equals to y minus 2 upon 1 equals to z minus 1 upon minus 1. This is required Cartesian equation of the line. See how simple it is. How simple it is. Very easy. Go through this, write it in your notebook. Okay, now the another question of similar type. Once again, we have to find the Cartesian equation. See, question number 6. Find the Cartesian equation. Find the Cartesian equations of the line passing through the point A minus 1 to 1 and having direction ratios 2, 3 and 1. Okay. So we have to find the Cartesian equations of the line which is passing through A minus 2, 1. We are not given 2 points on the line. We are given just 1 point on the line. So if just 1 point on the line is given, what other thing that we need? What is another very important thing? What is other mandatory thing that we need to know? What is another compulsory thing that we need to know? We need to know a vector parallel to the line. Are they giving the vector parallel to the line? No, but they are giving us the DRS of the line. Now remember students, if you know DRS of a line, sorry, if you know DRS of a line, you know a vector parallel to the line. Okay, so here I will start writing the answer as, I will write here, let me draw the line first. So here you have a line and one point of the line they give as A, negative 1, 2, 1. Okay, I write here, given A minus 1, 2, 1 is a point on the line. Okay, next 3 comma 2 comma 3 comma 1 are the DRS of the line. Now you know, with the help of this DRS, I can write a vector parallel to the line. I will write a vector parallel to the line. Therefore, a vector parallel to the line can be given as, a vector parallel to the line can be given as B bar equals to 2i cap plus 3j cap plus 1k cap. Okay. What do I write next? I write the Cartesian equation. See, I write here the Cartesian equation, of the line, the Cartesian equations of the line is given as, okay. Rather, we can write here plural because we have more than one equation there. So the Cartesian equations of the line are, okay, because we are having more than one equation in Cartesian form. So the Cartesian equations of the line are given as, see here, x minus x1 upon a1 equals to y minus y1 upon b1 equals to z minus z1 upon c1. Now, If you compare this with the previous question where you had 2 points on the line, you will notice that numerator remains the same. The numerator remains the same. See, x minus x1, y minus y1, and z minus z1. But the only change that you have is in the denominator. Here in the denominator, you have a1, b1, c1, which are the DRS of the line. See, this is a1, b1, and c1. 2 is a1, 3 is b1, and 1 is c1. In the previous case, when we had 2 points, we did not have the denominator as a1, b1, c1. Instead, we had x2 minus x1, y2 minus y1, z2 minus z1. Okay. So here I will write that is x minus x1. Okay. I should have written here. See, it is something that you should have written. Even if you don't write, it doesn't as such make a huge mistake, but then you should write. What is R? R is a variable point on the line. So here I will write let R x comma y comma z be a variable point on the line. So here we have x minus x1, x minus minus 1 upon a1. What is a1? a1 is 2 equals to y minus y1, that is 2. Y minus 2 upon 3 equals to z minus 1 upon 1. You see this z minus 1. This is x1, y1, z1, a1, b1, and c1. You got that? So we are substituting x minus minus 1 upon 2 equals to y minus 2 upon 3 equals to z minus 1 upon 1. So here we have that is x plus 1 upon 2 equals to y minus 2 upon 3 equals to z minus 1 are the Cartesian equations of the lines that is done. Okay, so here we have another question, number 4, and see how does it go. This question is quite interesting question, and such questions are expected in exam. So be very attentive. See, what does it say? It says that find vector equation. Once again, we are on to vector equation. Find the vector equation of the line. Find the vector equation of the line passing through the point having position vectors. Passing through the point having position vector. So what is this? This is position vector of the point on the line. See, they have said clearly passing through the point having position vector. So the line is passing through this point. Line is passing through this point. So this is position vector of a point on the line. I repeat once again, find the vector equation of the line passing through the point having position vector and perpendicular to the vectors I cap plus j cap plus k cap and 2i cap plus j cap minus k cap. So here I have these two vectors are those vectors to which the required line is perpendicular. See, clearly said, and perpendicular to the vectors, So the required line is perpendicular to these two vectors. Now here I want you all to be very, very, very attentive. Listen to the statements which now I am saying. Okay, students, in this question, they give me 1 point on the line. Now, whenever I have 1 point on the line, the next thing that I look for is a vector parallel to the line. If they give me 1 point on the line, as they have given, the next thing that I was looking for, that they should give me one vector parallel to the line. That is one vector which is along the line, along the direction of the line, but they are not giving us that. What are they giving us? They are not giving us a vector parallel to the line. Instead, they are giving us two vectors perpendicular to the line. Now see, unless and until I get one vector parallel to the line, I cannot solve the problem. I cannot solve the problem. I cannot proceed. I cannot find the equation of line unless I get two vectors, sorry, unless I get one vector parallel to the line. So see, how do I go ahead? I will take this as one vector. See, these are two vectors which are perpendicular to the lines. Let me take this vector as P bar and this vector as Q bar. Okay, so my line is perpendicular to these two vectors. My line is perpendicular to these two vectors. So what I will do is, the first thing I will do is, I shall find out, see, suppose these two vectors I have, okay, I have these two vectors, P bar and Q bar. P bar and Q bar, two vectors I have. So my line is perpendicular to these two vectors. My line is in the direction of, it is in the direction of perpendicular to these two vectors. My line is not in the direction of P bar. No, it is not like this. My line is not even like this. So what kind of line, what kind of direction my line is in? My line is in the direction perpendicular to both. So you will have to first find a direction which is perpendicular to both the vectors. I will have to find a direction which is perpendicular to both the vectors. Now see here, this direction is perpendicular to both the vectors. Here we have a direction which is perpendicular to both the vectors. I will find out this vector. This vector I will find out. And this vector is perpendicular to both the vectors. What is this vector then? This vector is P bar cross Q bar. P bar cross Q bar. This vector is P bar cross Q bar. Once again, what am I given? I am given two vectors, P bar and Q bar. Is my line, is the required line is in the direction of P bar and Q bar? No, it is not in the direction of P bar, neither in the direction of Q bar. So the required line is in the direction which is perpendicular to P bar and Q bar. So the first thing I'll have to do is find a direction which is perpendicular to P bar and Q bar. To find the direction perpendicular to P bar and Q bar, I will find out the cross product of P bar and Q bar. I will find out the cross product of P bar and Q bar. So I got this. This is the direction which is perpendicular. See, this is the direction which is perpendicular to P bar and Q bar. And my line is in that direction. So how is my line? This is how my line is. See, this is how my line is. My line is perpendicular to P bar and Q bar. Now I have my line. And which vector is in the direction of the line? Do I have a vector parallel to the line? Yes. See, this vector P bar cross Q bar. This vector P bar cross Q bar is a vector parallel to the line. As you know, we always needed a vector parallel to the line. So see, we got a vector parallel to the line, which is P bar cross Q bar. I have a point on the line. This is the point on the line, which is point A. And now I can solve the equation. I can find out the equation of the line. Okay. So let me draw this diagram properly now for you. So the same diagram I have drawn here. See, we are given two vectors P bar and Q bar. I will start writing the answer now. I will write here, let A is let A be the point, let A be the point on the line. So this is the point on the line. So what I will have, therefore A bar is I cap plus 2j cap plus 3k cap. Next, I will write let P bar and Q bar. See, they give me two vectors perpendicular to the line. So I will write let P bar and Q bar be the vectors perpendicular to the lines. Let P bar and Q bar be the vectors, perpendicular to the lines, to the line. So these are two vectors perpendicular to the line. So this becomes P bar and this becomes Q bar. I shall find out. Therefore, P bar is I cap plus J cap plus K cap, and Q bar is 2I cap plus J cap minus K cap. Okay. The required line is perpendicular to these two vectors. It means the required line is in the direction of P bar cross Q bar. If you have to find, this is basic, if you have to find perpendicular, if you have to find a vector perpendicular to two given vectors, what do? You find out the cross product. So here what I will do, see, I am given two vectors P bar Q bar. I will find out the cross product. I will find out the cross product. So what is P bar cross Q bar? P bar cross Q bar will be perpendicular to vector P bar and vector Q bar. So here I will write, what I will write? The required line is perpendicular to P bar and Q bar. The required line is perpendicular to P bar and Q bar. Hence, we can say that the required line, is parallel to, P bar cross Q bar. Why? Because P bar cross Q bar is also perpendicular to P bar and Q bar. Okay. So the next thing that I do is I will find out P bar cross Q bar. Okay. I will find out P bar cross Q bar. So P bar cross Q bar is, as you know, I cap, J cap, K cap, and now you have P bar as 1, 1, 1. Okay. Coefficient of I cap, J cap, K cap 1, 1, 1. So here 1, 1, 1, and Q bar coefficients are 2, 1, minus 1. 2, 1, minus 1. So we have therefore P bar cross Q bar is equal to I cap minus 1, minus 1, minus 1, minus 1. Okay. Minus J cap minus 1, minus 2 plus K cap 1, minus 2. So therefore P bar cross Q bar is minus 2 I cap plus 3 J cap minus K cap. Okay. So see, I got P bar cross Q bar. And my line, okay, now see, what is this P bar cross Q bar? P bar cross Q bar is a vector perpendicular to P bar and Q bar both. Now see, if P bar cross Q bar is perpendicular to both the vectors and the required line is also perpendicular to both the vectors, it means the required line is parallel to P bar cross Q bar. So how is the required line, my dear students? The required line will be like this. The required line will be in the direction of P bar cross Q bar. See, this is how your required line will be. Okay, this is the required line. This is the required line. The required line is parallel to P bar cross Q bar. Now what I will do, I will have one point on the line. That point on the line is point A. What is the point on the line? Point A. And the parallel vector, see, P bar cross Q bar is the parallel vector. Okay. I am given the position vector of the point. This is origin. So I am given A bar. I am given the position vector of the point. A bar. I will take a variable point on the line. Let R be a variable point on the line, and its position vector will be R bar. You're right. Okay, now whatever required things we should have, we have it. I need a point on the line. I have it. I have it. I need a vector parallel to the line. I have it. See, P bar cross Q bar, I have. I need a vector parallel to the line. So I have a vector parallel to the line. So I will write let R bar, let R bar, let point R bar be a variable point, on the line. Therefore, now students, look at this. Therefore, the vector AR bar is now parallel to P bar cross Q bar. Remember, earlier, what the parallel vector used to be, we would always take the parallel vector as B bar. You remember, we would always take that vector as B bar. So we would always write AR bar parallel to B bar. So we would write AR bar is equal to lambda B bar. But now what we will write? We will write AR bar is parallel to P bar cross Q bar. I will write, therefore, AR bar is parallel to P bar cross Q bar. Therefore, we can write. What you can write? You can now write AR bar is equal to lambda PQ P bar cross Q bar. AR bar is equal to lambda P bar cross Q bar. Because AR bar is parallel to P bar cross Q bar. So when the two vectors are parallel, one vector is a scalar multiple of other vector. So AR bar is equal to lambda P bar cross Q bar. Therefore, R bar minus A bar equals to lambda, and P bar cross Q bar, I have already find out, minus 2I cap plus 3J cap minus K cap. So R bar is equal to A bar plus lambda minus 2I cap plus 3J cap minus K cap. Therefore, R bar is equal to A bar. What is A bar? A bar here is, see, I cap plus 2J cap plus 3K cap. that is 1, 2, 3. So I cap plus 2j cap plus 3k cap plus lambda times minus 2i cap plus 3j cap minus k cap. This is the required vector equation of the line I hope you followed it. Very important problem. You can expect such questions in exam. Go through it, watch it again, listen to the whole solution and solve it.